Picture a predator moving through the dark, completely silent, completely unseen, closing in on something that has no idea it's being hunted. Now picture that predator as a dinosaur. That's not a movie scene. That's what the actual bone evidence says really happened. Here's the assumption almost everyone grows up with. Dinosaurs lived like the diorama version. Bright sun, wide open plains, hunting and grazing under a blazing daytime sky, then presumably going still and quiet the moment it got dark, the same way we assume most reptiles behave. But that picture isn't just incomplete. For at least one species, it's backwards. So how do you actually figure out whether an animal that's been extinct for tens of millions of years was awake at night or during the day? You can't ask it, you can't watch it, but it turns out you don't have to, because the answer has been sitting inside its skull the entire time. Inside a dinosaur's eye socket, there's a small ring of thin, overlapping bone plates called a scleral ring. It sits around the animal's pupil, supporting the eyeball's shape. And here's the part that makes it useful. The size of the opening in the middle of that ring, relative to the ring's overall diameter, tells you almost exactly how much light the animal's eye was built to let in. A small opening in a large ring means the eye was optimized for bright daylight, letting in just enough light without becoming overwhelmed. A large opening in a small ring means the opposite. The eye was built to gather every last scrap of available light, the same design you'd find in a cat, an owl, or anything else built to function after the sun goes down. Researchers have measured these rings across dozens of species, and most predatory dinosaurs land somewhere in the middle, active during the day but capable of functioning in low light too. But one species in particular stands out. Its scleral ring measurements are almost identical to modern nocturnal predators. Not similar, almost identical. Think about that for a second. This isn't an inference based on guesswork or behavior modeling. It's a direct physical measurement, sitting inside a fossilized skull, that lines up with animals we know for a fact hunt in the dark today. So what does an eye like that actually get you? For starters, massively improved sensitivity in low light, at the cost of sharp detail in bright daylight. That's a real trade-off. An eye built like this would likely have struggled in full sun, squinting through overwhelming brightness the way you would stepping outside after sitting in a dark room too long. Which means this wasn't an animal that could simply choose to hunt whenever convenient. Its entire visual system was specialized for one specific window of time, and it likely avoided the middle of the day almost entirely. Here's where it gets even more interesting. Eyes alone don't explain nocturnal hunting completely. You also need the rest of the body built around operating with minimal light. And there's supporting evidence here too. Researchers studying the inner ear structure of this species found unusually developed regions associated with balance and spatial orientation, the kind of internal wiring you'd expect in an animal that needed to move confidently through an environment it couldn't fully see. Moving fast and accurately without much visual information requires an entire sensory system built around it, not just better eyes. And there's a behavioral clue too, one that comes from an unexpected place, the fossil record of its prey. Several potential prey species from the same ecosystem and time period show evidence consistent with vulnerability during low visibility conditions, smaller body size, limited defensive features, patterns that would make more sense if the greatest threat these animals faced wasn't a daytime chase, but something they couldn't clearly see coming until it was already too close. None of this proves the predator was exclusively nocturnal. Very few animals, even today, operate in a single rigid mode all the time. Most likely, like many modern nocturnal hunters, this dinosaur was capable of daytime activity when necessary, but built and optimized for something else entirely: movement, hunting, and survival, specifically after dark. So why does this matter, beyond being a strange biological detail? Because it fundamentally changes the picture of what an ancient ecosystem actually looked like. If you're imagining prehistoric life as one continuous daytime scene, populated entirely by animals hunting and grazing under bright sun, you're missing an entire half of the story. As the sun went down and most large daytime predators became less effective, a completely different set of rules would have applied. Different hunters, different vulnerabilities, an entire second ecosystem operating in parallel with the one everyone pictures, active only after dark.